Hey guys, last one. This is 19B. We're going to look at the evidence for global warming. So this is kind of going off of the last section where we're talking about some of the consequences and the effects of the greenhouse effect. Now we're going to look at what are the specific ramifications and also the evidence of it. All right, so first of all, when we go about explaining how we know that global warming is happening, how we know that it is humanly caused, we're going to get into looking at methods of looking at CO2 concentrations, not just during the Industrial Revolution, but looking through as much of natural history as possible, right? So we're going to look at some places where there are very good records, right? And they're going to look at various sources, okay? They're going to look at how the temperatures have increased since 1880, and they're going to look at the records of that specifically. And we're going to discuss how we estimate temperatures and levels of greenhouse gases over the past 500,000 years and into the future, right? We're also going to look at how climate change kind of works with feedback loops, right, both positive and negative. All right, CO2 concentrations have been increasing for the past 6 decades according to our data. Okay, what you need to know is this idea of ocean acidification, the process by which the surface part of the ocean, the CO2 increase causes the CO2 to convert into carbonic acid, right? It reacts and switches places with hydrogen ions in H2O, and you end up creating carbonic acid. This lowers the pH of the water. Remember that lowering pH is becoming more acidic. And remember that if you go down by a pH of 1 for every 1, remember that it's logarithmic. So it means if you go from a pH of 7 down to 5, even though that's just 2 jumps, that is 10 to the second. That is 100 times greater. Okay, so you need to know that. Okay, which lowers the pH of the water, right? And why is that such a bad thing? Well, animals that live in the water, marine life, may be suited to a very narrow range of pH, right, acidities. So those creatures that are now put into a different pH concentration are not going to fare so well. Okay. Also worth noting is that a lot of your coral and things like animals with shells, they have calcium carbonate material in their shells, right? And they're going to react with the acid in the water. It's going to dissolve, right? It's going to make it harder for them to live. You end up with coral bleaching as well, where the coral actually ejects some of its algae, single-celled algae out from the pores, and then it ends up dying because it no longer has its source of food and oxygen. Okay, but anyways, let's take a look at this graph. If we look at the parts per million CO2, we see that in the last 50 some odd years that CO2 has trended upward. So we have some monthly averages. And why might we have monthly averages? Why do we have kind of this cyclical sort of pattern of CO2? Well, the Earth breathes, right? So kind of remember that. Our planet Earth breathes. What on Earth takes in CO2? Plant life, right? And during the day, the plants breathe in and breathe out at night, and they take in CO2 the same way that we would take in oxygen, just in the opposite cycle, right? That's cellular respiration. And certain times of the year, there's more sunlight than others, right? So the level of sunlight is going to determine how much of the CO2 is either breathed in or breathed out, depending on the time of the year. So that's why we have this kind of cyclical pattern here. But if you look, that pattern is cycling and trending upwards, right? So the overall trend is going upwards. And we're going to look at the range of historical CO2 concentration in the next couple slides. You're going to see that it's very stunning that we're approaching, and actually we've gone over 400 in some places in the world, right? CO2 emissions differ among nations. That's pretty obvious, right? So the United States is way, way up there, right? China, of course, is beating us, but that doesn't say much because China is a much bigger country than us. They're developing. They don't have as many clean air technologies, and we'll get into some of like the ethical debates as to whether or not they should in just a second. But remember, the United States is a little less than a third than the population of China, actually like a fourth, and yet we have a very comparable CO2 emission. That's kind of troubling, right? Considering we don't have as big of a production of coal power as China does, right? Just raw numbers, right? Percentage-wise, we have quite a bit, but China in the last couple of years, as you remember from the last lecture, has more than doubled its coal plant production in the last 10 years. Yeah, you look here, there's other countries there, even India, which is a developing nation. Keep in mind that both India and China, these guys are not part of the Kyoto Protocol. Kyoto Proto, they are not part of it, okay? So that's part of the reason why China is kind of running roughshod with CO2 emissions, but India is not, strangely enough, right? But maybe in the next couple of years they will, who knows? So let's see here, let's get this out the way. All right, so here's our per capita consumption. Oh, look, now America's back up on top. So per capita, why do you think that the per capita CO2 emission is so much higher here? Well, all of us have our own vehicles, right? And they're usually, we don't really put a whole lot of emphasis on carpooling and public transportation. So we're gonna have much higher per capita CO2 emission. Now look here, down here in China. Keep in mind that this is mostly because a lot of China, even though it's a developing nation and there are a lot of leaps and gains in their industry, that a lot of people out in the country, in the rural areas, are mostly left behind, right? They're migrating towards the urban areas, but not everybody in China is likely to have a vehicle, whereas in the United States, even if you are relatively not well off financially, you are likely to probably have a car at some point in your life. All right, now let's look at the global temperature and how it's steadily increased in the 1880s, right? Since we've been taking records in the 1880s officially, we've had an upswing of global temperatures. And let's see, so our annual average, that kind of goes up and down, kind of wonky and everything, but you can see that it's kind of stepping upward over time. The 5-year running average shows a little bit more consistent trend upward. Okay. And this is one of the ways that we know here. We have biological records here, and this is something that we used to go back hundreds of thousands of years. Okay, so now we have the human record, what we've officially taken and averaged over the last couple hundred years. But this is what we've had for the last 500,000 years. Okay, so these little guys right here, the way that we ascertain what the temperature must have been like in the past using these is that certain species of these creatures will thrive at different temperatures, right? So if we go and look at the fossil records, sedimentation, things like that, so the different sediments laid down in chronological order. As we go down, we look at different concentrations of these foraminifera, and depending on the concentration of the specific species, like the percent composition, we can tell what the temperature must have been like back in the day. And of course we use that in conjunction with other things, but most of the time we can use this and kind of look and compare it to present times and see if it's consistent with CO2 levels and temperature. And then we use that and kind of retro use it and try to and work backwards, right? So that's one of the ways that we have craftily looked at CO2 levels in the past 500,000 years or so. And so we know this is a fairly accurate assessment that CO2 levels in the air are higher than they've ever been since the foreseeable past. Okay, here's global temperature since 1880. Here's a graph of that. Here's a nice little color chart. You'll need to be able to read graphs like these, so make sure that you are very comfortable with it. In 2010, some regions became cooler, some regions had no temperature change, and the northern latitudes became substantially warmer than the long-term average temperature. So you need to see this right here, that the Antarctic has actually gotten a bit cooler, right? It's actually gotten a bit cooler in some spots. You need to know this too, that the ice sheet in Antarctica has actually grown in area. So down here, this has actually increased in area, but, and this is a big but, the thickness, right? Has actually gone down, right? This thickness has gone down. So the area has gone up, but the thickness has gone down. That means there is much higher water around the world globally because collectively of the decreases in the ice sheet in the north and the south, right? So even though the area down here is increasing because it's getting a little cooler in these spots right here, it is not, we do have increasing water levels, right? And it has been multiple millimeters, right? So this is quite a big change already. A lot of places in the world are already seeing the effects of higher water levels, right? There are islands out in the Pacific that are within the next few years going to be completely underwater, just a few inches, but it means that you can't live there anymore. Hurricanes and very big tropical storms really like water, so the higher up on land the water goes, the more friendly it's going to be towards those storms and hurricanes. That's why we're getting these big superstorms in the Northeast. All right, so we can kind of estimate, here's another way we can estimate the greenhouse gases concentrations in the last 5,000 years. And we get these little ice cores, right? And these ice cores in the Arctic, which have been mostly undisturbed. If you go higher north latitudes, will have very similar to the way we get fossil records, sedimentation, but different water will freeze with different concentrations of air bubbles, and those air bubbles will have CO2. And you can see here that we can open these up, we can thaw this out, and we can take a little measurement with a little CO2 probe, gas probe, and we can look at the parts per million that way. And if we combine this with our foraminifera analysis, we can kind of see if we have the right idea, right? That's one thing. If you're designing a lab or something like that, that's something you'd want to think about, right? Like combining multiple methods to kind of verify the validity of each other, right, and see if it's consistent. Now, look here. Here is our parts per million CO2. Notice that it's kind of just going in between a little under 200 million up to right about 300 million. And then all of a sudden, so this is happening for, look at the scale here, 50,000 years per notch. So this is, we don't have industry here. We're not doing all kinds of crazy things with factories. And then all of a sudden, look, in this little blink of an eye, it shot up to 400 parts per million. And actually, it's over 400 parts per million now. This is so now we're going to talk about what could be the sources of this. Historic sources of greenhouse gas. So ice cores used to estimate the historic temperatures of CO2 concentration indicate that the two factors vary together, right? So one of the arguments against global warming caused by CO2 and that the progenic emissions of CO2 is that, well, it could just be that things are getting hot and that the CO2 is not a consequence of, is a consequence of global warming. It's not really causing global warming, right? Because of course, if you're heating up the water, you're letting more dissolved CO2 get out, because we know that gases are not soluble in higher temperatures. If you're melting things out, of course, you're going to thaw decaying organic matter, and you're going to let a lot of like CO2 and methane out. So how do we know it's not that it's just getting hotter naturally and the CO2 is a result of that? Well, if that were the case, then we wouldn't be getting higher average temperatures at night, right? So this is something to remember, that the temperature increases happen at night. They happen in the winter. So these are some things to think about. And also keep in mind that the coldest regions in the world are having the highest increases in temperature, right? So it's not that it got so hot in the coldest regions in the world and that's why the CO2 went out. It's quite the opposite, right? So just kind of keep those things in mind. In addition to CO2, all of the other really bad greenhouse gases that you can think about, whether it's our NOxes or nitrous oxide, N2O, and CH4 methane, all of these things are way off the charts, and they're using very similar metrics to kind of figure those things out. All right, so I'm going to move this over here real quick. All right, so let's look at this. So just remember that one of the biggest arguments against global warming is that there is an input. If we look at just input of solar radiation, you know that the sun over the last millions of years or whatever does have some increase in solar output as it exhausts a little bit of the hydrogen gas. It has to tighten and squeeze down a little bit, and then it'll heat up, and then it'll get a little bit brighter. But all of the things that are happening right now are not consistent with that heating up, right? It takes a lot more, since we're so far away from the sun, it doesn't cause that appreciable of a difference in temperature than what it would be consistent with what we get from just greenhouse gases. All right, so just keep those things in mind. All right, here are some climate models and the prediction of future global warming temperatures based on what's going on right now. Keep in mind that when you hear criticisms of things like Al Gore's The Simple Truth, or The Inconvenient Truth, The Inconvenient Truth, which talks about global warming, they're like, yeah, all these predictions are wrong, and they are a little bit right to the extent that they were wrong about some of the very specific amounts of changes in like sea level and things like that. But overall, the inaccuracies were just at how conservative of an estimate they were, because their most dramatic estimates are usually far below what's happened in the last 15 years. So they were wrong mostly in just that they weren't dramatic enough, right? Because a lot of the things that are happening are outpacing some of the more bleak outlooks of that documentary. So you can kind of see here, like, these are some of the things that are going to happen. So if you look at some of the latitudes that are the poorest, right around the equator, right, you see this right here. Look what's going to happen to them. Right, this is really going to cause a lot of problems for them. Look up here. These biomes are, if you think about your study of biomes and climates, weather patterns, right, look at this. Right, all these things up here where there would be thermohaline currents, right? Thermohaline currents, which is a mixing of cold water and hot water, salty currents, which circulate nutrients around the globe. These are going to be affected, right? These are really, really going to be affected. Right, that can destroy entire biomes by limiting the limiting factors that go there. So just keep these things in mind. This is just a comprehensive view of everything you've learned, and now it's kind of looking at climate change. All right, so here's some feedback loops that are caused by climate change. Decomposition is a positive feedback loop. More carbon dioxide in the air causes a higher temperature, which increases the rate of decomposition because bacteria, metabolic rates of bacteria and breaking down dead, decaying matter increases with temperature. But it also exposes a lot more things like permafrost, which was previously completely frozen, permanently frozen, and now it's not. So all that stuff is going to be released into the air, which then, of course, really increase the temperature, increases composition. Positive feedback loop, great. Okay, negative feedback loop. Here's one that has to do with climate. You need to know this one because whenever you think climate change, you think negative, but you need to think about something that will benefit the plants, right? So because there's increased CO2 in the air, potentially speaking, if we don't clear cut the entire forest, if we don't do what our current administration is saying, and we'll leave a little bit of the environment, but we can't hurt business. If we don't cut down the entire forest, that CO2 could potentially be sequestered into plants, right? And that'll be taken up for a long time. And because there is a decrease in atmospheric CO2, or because there's an increase in atmospheric CO2 from global warming, we can grow more plants. And that's kind of a negative feedback loop. It takes a little bit more out of the atmosphere. But you have to keep in mind that this is not an infinite cycle. This is not an infinite cycle. There is a limit to which plants can grow, right? You think of some other limiting factors that plants might need. Well, there is nutrients, of course. And there's also water, right? And just habitat, right? And this really has to do with humans. Okay, so just keep that in mind, right? So you could have all the CO2 in the world, but at a certain point you're going to run out of some other limiting factor like water or space. Okay? Just keep that in mind. These are two feedback loops you need to know regarding to CO2. All right, so consequences of global climate change. So after reading this module, you should be able to discuss how global climate change has affected the environment, explain how global climate change has affected organisms, identify future changes predicted to occur, and explain global climate change goals of the Kyoto Protocol. All right, so let's look here. Melting of the ice caps in Greenland and Antarctica has some really, really big ramifications. Rising sea levels due to the melting of glaciers, and the fact that water tends to warm as it expands, right? Remember that it expands as it warms. It also expands as it gets down to about 3 degrees Celsius. And frozen solid water is less dense, which is kind of an anomaly. It's different than liquid water. Okay, we're going to get heat waves, cold spells, changes in precipitation patterns, and increase in storm intensity. Just keep in mind that global warming is just a small aspect of climate change, right? And so climate change is a little bit more accurate description of what's happening. And because we weren't as specific, ironically, about the actual term that we should have been using back in the day, proponents against climate change will use the fact that we have sometimes colder winters and cold spells to kind of discredit the idea of global climate change. All right, and here's some of the things that just before we get into it, melting of permafrost, right? So here's permafrost right here, and this is previously frozen ground. And as this gets thawed out, there's layers and layers and layers of organic matter that is now going to be exposed. So you're going to get a lot of CO2 and even much more methane, which is very bad. All right, so let's look here. Okay, so these are polar ice caps melting. Because northern latitudes have experienced the greatest amount of global warming, the extent of ice cap near the North Pole has been declining over the last 3 decades. Polar ice cap, it's kind of cyclical, right? It reaches a minimum in late summer of each year. But just keep in mind now that the spring and summer is lasting longer. So the warm seasons, these are longer in duration now because it's starting earlier and ending later. And this has lots of effects on things like polar bears and these icy biomes, because guess what? If your job is to jump from a little ice sheet to ice sheet and find things to eat, but now the space between these ice sheets is growing considerably. So maybe before it looked something like this, right? You just had to be able to swim across this little gap right here in the water, but now we have something that looks more like this. So I can actually move one of these. Oh, those all moved at the same time. So now we have something that looks more like this. So here's your first ice sheet. Here's your second ice sheet because they have melted. Now the chances of you being able to swim this far are going to decrease, right? Or it takes a lot more energy to do that. Your access to food is much more limited. So as a result, the average size of polar bears has decreased quite a bit in the last 50 to 100 years. All right, so think about it now. Natural selection is not favorable towards large, big, strong polar bears. It's going to be more favorable towards small ones, right? Because they're able to survive off of less. All right, so declining ice sheet in Antarctica and Greenland. So here's the measurements here. Okay, so this is already affecting organisms for the reasons that we talked about earlier, and of course it affects more than just polar bears. Humans are going to have to relocate. This is already happening in some islands, off the Florida Keys and things like that, now in the Pacific Ocean, that are already starting to get covered by water. Coral in particular, they're very, very sensitive to global warming because they are very sensitive. Like, they really don't like to be in things that they were not adapted to live in, right? So we're getting quite a bit of coral bleaching. So just remember that. Coral bleaching. We had a big problem with this in the Great Barrier Reef earlier this year. Okay, so let's look here. So the Intergovernmental Panel of Climate Change. You need to look at this graph and make sure you know these. These are all pretty likely that they're humanly caused. Just very, very bleak. We need to do something about this. All right, let's talk a little bit about the Kyoto Protocol and a little bit of the politics behind it. So the goal of the Kyoto Protocol was to have all of the countries that bought in, all the developed nations that were really big offenders of CO2 in their history, reduce their CO2 emissions by 5.2% below their 1990 levels by 2012. The U.S. did not sign on to it. Al Gore urged President Clinton to sign it and just commit the U.S. to it, but since it was never ratified by Congress, it is not legally binding, right? So that allowed President Bush to come in and go, well, I think that humans and fish can live in harmony. That's actually something he really said. But more importantly, he said that there isn't enough consensus scientifically on whether or not global climate change is caused by CO2, so we're just going to not be part of that. Really, really interesting. Like I said at the beginning of the lecture, China and India were not included in that because I said historical offenders of CO2 emissions. And since they are developing, they haven't had a chance to really industrialize and take advantage of nature's fuel sources. And so there are a lot of ethical questions about, should developing nations in the modern era be held to slightly higher standards, stricter standards for CO2 emissions than European countries were, because we can play this whole, like, it's not fair, but we know better now, right? So what does that mean for us? Should we let them kind of take the brunt of the economic burden to develop cleaner technology as they're also trying to develop their economy? A lot of people might say that's very, very unfair. So maybe it's something that the developed nations can help with. Maybe they can help subsidize some of that clean technology, or maybe co-develop cleaner alternatives, right? At any rate, you know that China is the #1 producer and exporter of solar technology, so we really need to kind of get up on that, and just make sure that we're competitive, right? So it's not just if you don't want to just race to the top for alternative fuel technologies because it's good for the planet, we're going to get left behind, and we're going to end up being we're going to end up looking to China for jobs in industry and solar. So just keep that in mind, right? So the U.S. signed the original Kyoto Protocol, but Congress never ratified it. So as a result, a lot of different mayors from the U.S. ended up ratifying their own little agreement where they were going to try to stick to and adhere to the Kyoto Protocol, and they were going to show that it's economically feasible, it's not going to hurt business, and that we are serious about it. We're going to try to make it almost an embarrassment if we don't get along with all this, right? Okay, so let's talk about carbon sequestration. We've already seen this term quite a few times this year. You know that it basically just means to lock up carbon in some way for a long period of time so that it's no longer in the regular cycle of atmospheric above ground CO2. Remember that there was a difference between modern carbon, which cycles constantly. So if I draw like the Earth, I draw the Earth like this. So here's the surface of the Earth, and here's the atmosphere. And I'm just going to make carbon red for right now. So modern carbon is all the stuff that cycles like this. There's little arrows. So it's going to cycle above ground, whereas you had fossil carbon or ancient carbon, right, which is mostly going to cycle, or it's actually not cycling at all, it's just stuck underground, right? And this could be oil, gas, and things like that, right? Okay, so this stuff right here, sequestering means that we're taking the stuff that's up here and kind of eliminating some of it, right? We're eliminating some of it. Ideally, we'd like to do that, eliminate all of it, but not all of it enough so that we're not having these catastrophic above 350 parts per million CO2 in the air, right? But we'd like to get rid of at least a little bit of this stuff, right? And sequester it and make it more permanent so it's out of the regular above ground rotation, right? So sequestering, some ways we could do that is just allowing some agricultural soils to stay out of use for a long period of time, let it become pasture and forest. We know that forests are basically gigantic pillars of CO2, right? And if we don't cut them down right away, it can keep them in there for very long periods of time. Why not develop technology that will actually actively remove CO2 from the air and from coal burning power stations? This is not a developed technology yet. It's something that's kind of being researched, and it would be nice in the future. And it's part of the reason countries like Canada and Russia have left the Kyoto Protocol, saying that we can develop technologies that will do this right here, and it will not only benefit us economically, but it also won't hurt us economically by forcing us to kind of hamstring ourselves with industry and worry about cutting down CO2s. Like instead of cutting CO2 down and going kind of with the precautionary principle of risk assessment, which the Kyoto Protocol is similar to. Instead of doing that, we're just going to go ahead and develop technologies that will not only get money, but it'll solve this problem for us. I tend to think that there should be a combination of both, because there is no guarantee that this technology will occur, right? Even though we are a very industrious species, I think we need to do everything we can in the meantime. Okay, so this was apes, all of it. What do you think? You think you are a better citizen as a result? Do you think that if you maybe have some doubts about some of the things we've learned, that you at least are equipped with the tools to question it and go about researching your ideas and verifying the validity, the veracity of some of these arguments and claims? That's been the goal that I've had, is to present you with as much information as possible and have you come to your own conclusions. And whether you agree with every topic and opinion that I've had this year, that you are at least maybe a little bit more critical thinker, or you appreciate your ability to question and learn. Right, so take these things with you regardless of what you study. Remember that you're part of this world. Okay, you're part of this world, whether we're talking about economics, whether we're talking about human rights, whether we're talking about municipal legislation, urban blight, environmentalism, biomes, save the whales, save the trees, save the bees, save your grades, save your behind. No matter what it is that gives you skin in the fight, remember that you are not disconnected from any issue. Okay, you whether you look into an issue or not, whether you're active or not, it affects you. So just keep that in mind. The more knowledge that you have, the less likely you are to be taken advantage of by somebody who's looking to make a buck off you or looking to disenfranchise you. Okay? So good luck, and let's kick some butt on the AP test.